So today we're going to work on trig functions of any angle, again, chapter 6, section 3, but we're going to focus on part 2, which is slides 4 to 7. So here we're going to start working with our graphing calculator, okay? Notice that your calculator, I think it would be good at this point if you converted it to radians. Remember, you're going to go to your mode and you're going to select radians, okay, as opposed to degrees. So what happens is now, instead of, we don't have, like, we're not using the reference angles that we can use the unit circle for. Remember, the unit circle is helpful for, the unit circle will help us for quadrantal angles, okay? Those are the angles that fall on the actual axis lines, like 0, 90, 180, 270, 360, etc. And again, as in terms of radians, that would be, 0, obviously the pi over 2, pi, 3 pi over 2, and 2 pi, okay? And then it's also good for the special angles, okay? Like we've got 30, 60, and 90, okay? And for those, it would be, pi over 6, not 90, let me fix that. It'd be 30, 45, and 60. Sorry about that. It'd be pi over 6, pi over 4, and pi over 3, respectively, in terms of radians. Now what we're going to do is we're going to find values of cosine and sine and things like that of other values that are not these up here. So what you're going to do, you're just going to go to your calculator like you did before. You're going to make sure that it's in radians, and you're going to actually find the cosine of 1.85, okay? And you're going to hit the cosine. And so first of all, you have to recognize that this is 1.85 radians, okay? This is not 1.85 degrees. And your answer is going to be, they want you to round it to 4 decimal places. So it's going to be negative 0 point, and then we've got 1, 2, 3, 4. Okay, that's 4 decimal places. So the cosine of 1.85 radians is approximately negative 0.2756. And again, you might ask yourself, well, is that accurate, right? Should it be negative? Should it be positive? I mean, you're using the calculator, so at the end of the day, you know the calculator is going to give you the right amount if it's in radians and you did it. But remember again that you're starting at 0 radians and you're ending at about 6 radians. We know that then 3 radians is going to be about here. So this is about 4.5 radians, and this is about 1.5 radians. So cosine of 1.85 radians is going to be in this quadrant. And we know that the cosine is negative in that quadrant, so it does make sense, okay? But again, you're using your calculator, so we've got 0.5149 is the value. We want the cosine of that, and we're going to get that it equals 0.8703. That's our cosine, okay? And once again, think about your angles, right? Again, this is 0 and 6. Approximately 6 is about 1 revolution, 1.5, 3, and 4.5. And you're like, oh, 0.5 is in this quadrant. And yes, the cosine would be a positive number. So I'm not going to check every single one, but you should make sure, especially in an assessment, that it is in the right location and it does make sense, okay? Now, the cotangent, remember that the cotangent of an angle is the same as 1 over the tangent of that angle, okay? So this problem, if I want the cotangent of this angle, it's going to be the same as 1 divided by the tangent of 1.3209. And so that's what I'll enter into my calculator. It'll be 1 divided by, and it'll be 1.3209, or at least the tangent of that number. And I'm going to get approximately 0.2552, rounding to the nearest, to 4 places. Okay, so that's going to be my cotangent of that value. Again, secant of negative 2.9234 radians. Well, I know that the secant is going to be equal to 1 over the cosine of that exact same number. And guys, be really careful when you're typing this in your calculators. 1 divided by the cosine of 2.9234, cosine of that, and I'm going to get approximately equal to, my secant is approximately equal to negative 1.0243. And be careful, guys, double check it. You know, type it in twice just to make sure you got the correct values, just to be safe on these. The sine of 0.8203 radians, so 0.8203 radians, and the sine of that is equal to approximately 0.7314. Again, rounded to the places we tell you. And then the last one you've got here, 5.2825, or negative, and you need the cosine of that number. And it's going to be approximately 0.5397. And so that's how you just plug these in. Okay, last one, tangent of 6.4752 radians. So again, these are really easy. 6.4752 radians, hit the tangent button, and you get approximately 0.1944. And that's your answer. And so double check your answers to make sure you did them correctly. But if you know your reciprocal ratios, you know how to utilize your calculator, you have it set to radians, and you're careful, round to the right thing, this should be automatic, easy questions for you. Now we're going to talk about those reference angles again like we did before, because what happens is now we're going to be working backwards. We're going to be trying to figure out what angles have a particular sine or cosine or tangent or whatever. And so we want to think about, how do we find our reference angles? And so remember that when we were dealing with degrees, okay, so oops, I don't want that. When we were dealing with degrees, right? When we were dealing with degrees in each quadrant, we said that the angle, or we said that theta, okay, let's just say, that theta equaled the reference angle, okay? In quadrant 2, we said that 180 minus the reference angle, or theta equaled 180 minus the reference angle, okay? In quadrant 3, we said that the angle, or theta, equaled 180 plus the reference angle. And in quadrant 4, we said the angle was 360 minus the reference angle, okay? Now, this was in degrees, okay? This is how we found the reference angle in each quadrant, okay? Now, if we're talking about radians, then we know that theta in radians is going to be the reference angle, okay? In quadrant 2, it's going to be pi minus the reference angle. And again, the reference angle is also known as, reference angle is theta prime, but we just call it reference angle, okay? But again, it's going to be pi or 3.14, okay? Remember, pi and 3.14 are the same. And so in quadrant 3, it's going to be pi plus the reference angle or theta prime. And in quadrant 4, it's 2 pi minus the reference angle or theta prime. Okay, and so again, you can use 2 pi, or you can use 6.28, you can use pi, or you can use 3.14. So that's how we're going to get that. So for example, if I know that my reference angle is 30 degrees, which is equivalent to pi over 6, and I want to know what is that angle in each quadrant, right? I know that that's going to be, in this quadrant, it's going to be pi minus pi over 6. Now when I do the math, pi, I can convert it to 6 pi over 6 minus pi over 6, and so I know it's 5 pi over 6. So I have to kind of turn pi, okay, here, or 2 pi, into something with a denominator that matches the denominator in the reference angle. So let's go to the next slide. So here it says use your calculator to find the value of theta on the interval of 0 to 2 pi. Round your answers to the nearest hundredth. So I need to figure out what values of theta in radians, okay, is going to give me a cosine of 0.9685. Now, again, this is something we covered on our last assessment, and we know here that we have all students take calculus. And if you notice, my cosine is a positive value. Well, there are only 2 quadrants where my cosine is positive, and that's going to be in quadrant 1 and in quadrant 2, okay? And so I need to figure out what is the reference angle so I can find the angles in those 2 quadrants. Quadrant 3 and quadrant 4 are out because I know that my cosine is negative in those. So even if this value were negative, I would go to my calculator and I would find, or type, I would do cosine, inverse cosine 0.9685, and I would get, this is going to give me my reference angle, okay? So 0.9685 inverse cosine, and it's going to equal 0.25, and it tells me to round my answers to the nearest hundredth. Okay, so 0.252 is going to be my reference angle. So this is 0.252 radians, okay? That's the answer that I've got. That's my reference angle, okay? So again, in quadrant 1, my answer is that angle. So 0.252 radians is going to be one of my answers. And then I'm going to use that reference angle in quadrant 4, which I know is 2 pi minus 0.252 radians. So I can come to my calculator and I could either just do 6.28 minus 0.252. So 6.28 minus 0.252, and I'm going to get 6.028. And I know that that's my second angle. So I have 2 answers to this problem. There are 2 angles in this interval which have this cosine, and those 2 angles are 0.252 radians and 6.028 radians. Okay, and I know that that is my answer for that. Okay, those are my 2 solutions. One is in quadrant 1, and one is here in quadrant 3. So what happens is that this is my reference angle, 0.252, but the angle that I'm looking for starts here and ends here, and it ends at that line. And that circle, that almost complete circle, is equal to 6.028 radians, and that's the angle that ends at that terminal side. So those are the 2 answers for that problem. When I go to the next one to the right, again, I'm looking for the cosine of theta in radians or I'm looking for the angle in radians that has a cosine of 0.7826. So I have to start again. I know it's cosine. I know that means all students take calculus. I know that means if it's positive that these 2 are out, and I know my answer once again is going to have to come from quadrant 1 and quadrant 3. So my reference angle, I'm going to do cosine, inverse cosine of 0.7826, and I'm going to get my reference angle. So 0.7826 inverse cosine, and I'm going to get 0.672. That's my reference angle. Remember, in quadrant 1, your reference angle is the same as theta. And so I know that that's going to be my first angle, 0.672. In the fourth quadrant, again, that's my reference angle, 0.0672. But I'm going to need to figure out what angle is going to end there. And I know the angle is going to be 6.28. It's either going to be, we could do 2 pi minus 0.672. Let me kind of write that the right way. That's my reference angle, right? And so I'm going to get, again, plus 6.28. And I'm going to get 5.608. And so I know that that is going to be my angle. So that's my second solution. So my solutions are going to be 0.672 radians and 5.608 radians. Those are the 2 degree measures, or not degree measures, radian measures, angle measures that will give me that cosine. And again, you can work it backwards. You can just type in your calculator now, take 5.608 and actually find the cosine of it, and it's 0.7805. Now what's interesting is when I did it backwards, I didn't really get the exact answer. And the reason is because I'm doing, unless I did the math wrong, I'm doing 2 pi. That's what I feel like I should be doing on my calculator, 2 pi minus, as opposed to 6.28. I don't really like rounding it. So for me personally, let me try 2 pi specifically. 2 times pi equals, let me see, 2 pi, 2 times pi equals minus 0.672 equals. So if I do 2 pi as opposed to 6.28, I get 5.611. And then if I do the cosine of that, 0.611. Yeah, I get a lot closer to this when I use 2 pi. So yes, you can do, the other slide did show 3.14 for 180 and 6.28 for 2 pi. But for me personally, I prefer to do 2 pi minus that number, or pi minus, and use your calculator, okay? I think your answer comes out more exact. So that's what I would definitely recommend. And I guess we'll tell you on the test which, if it's multiple choice or something, which we prefer. Okay, then we go here to cosine, or cotangent rather. So we're trying to find out which angle measure in radians has a cotangent of 0.2994. So we know that the tangent of this angle in terms of theta, right? The cotangent of the angle, or the tangent of the angle, is 1 over the cotangent of that angle, right? Or theta or whatever. So I know that I'm going to do the tangent equals 1 over 0.2994, because that's the actual cotangent. So I'm going to do the inverse of that, right? Because now I'm trying to find what angle makes that happen. So I'll do 1 divided by 0.2994, and I get 3.3 something, and then I'm going to hit the inverse tangent. And I know that my reference angle is 1.2798, which simplifies to 1.280. So that's going to be my reference angle, 1.280 radians. And again, now I look at my cotangent and I see that it's positive. All students take calculus. And I know my tangent and cotangent are positive in quadrant 1 and quadrant 3. And so I know that in quadrant 1, the reference angle is the answer. So I know that here, this is one of my values. Okay, that's going to be 1. And the second one is going to be in quadrant 3, and it's going to be pi plus 1.280 radians. And again, I'm going to use pi and actually add it to that, 1.280. And I'm going to get the angle is approximately 4.422. And so that's the second angle, is 4.422 radians. All of these are in radians, okay? So again, my reference angle was this. In quadrant 1, the solution is the reference angle. In all the other quadrants, I have to either add or subtract something to it. I have to figure it out per quadrant. Now, the last problem is the one that gets a little tricky. They're looking for the sine. They're telling me the sine of, or they're looking for the theta again in radians, and they're telling me that the sine of some radian angle measure is negative 0.3425. Now, so I know that I'm going to do inverse sine of, but instead of doing the negative, I'm going to wait on that, and I'm just going to do the positive in here. I'm going to use the negative to determine my quadrant. I know my quadrant, all students take calculus. I know that my sine is negative, okay, not in quadrant 1 or 2, but in 3 and 4. So I know that negative here, okay, is pointing me to the fact that my answer is going to come in these two quadrants, okay? But to find my reference angle, it's easier if you just plug in the positive value. So I'm going to do 0.3425, and I'm going to take the inverse sine, and I'm going to get my reference angle, which is going to be 0.3495, which means 0.350, okay? So my reference angle is basically 3.5, or 0.35. So in quadrant, I know my answer is going to come from quadrants 3 and 4. In quadrant 3, I do pi plus the reference angle, 0.350. And in quadrant 4, I do 2 pi minus 0.350. And I'm going to get my two angles. When I do 0.350 plus pi, I get 3.492. And when I do 2 pi minus 0.350, I get approximately 5.933 as my reference angle. And so those are my two reference angles for this problem. So not my two reference angles, those are my two angles. Those are my two angles that have a sine of negative 0.3425. Okay, so what I do is I use the negative part of this just to figure out my quadrants, 3 and 4. Then I use the positive part of it with the inverse to find my reference angle, rounded to the nearest hundred. Once I have my reference angle, I apply it to the proper quadrant with the proper formula. Since I'm in quadrants 3 and 4, I know that for 3 I do pi plus that reference angle, and in 4 I do 2 pi minus the reference angle. And for us, I think I would use pi in the calculator and not limit it to 6.28 for 2 pi or 3.14. Okay? And I think I've answered, I think I skipped one here. I believe I skipped number 19. Last one on this slide, I've got the cosecant. And I know if the cosecant is, there's definitely a problem here, right? 1.0. I think this is the mistake here. I'm going to say, I think it would be 1.0219. Let's try that, okay? So let's get rid of that other one. So I know the cosecant of some angle equals this. Well, I know that the sine of that same angle is going to be 1 over the cosecant of that angle. So the sine equals 1 over the cosecant. And so I know I'm going to set it up like this. So this inverse sine of 1 over 1.0219 is going to give me my reference angle. So I'm going to do 1 divided by 1.0219. I'm going to get that answer, and then I'm going to find the inverse sine of it, and my reference angle is 1.363. Okay? So this is my reference angle. Now I think about in what quadrants is my cosecant positive. And I know that my cosecant goes with my sine, and my sine is positive in quadrants 1 and 2. In quadrants 3 and 4, my sine and my cosecant are negative. So I'm going to identify my angles using the formulas for quadrants 1 and 2. So I know in quadrant 1, I know that my theta is going to equal the actual reference angle, so 1.363 radians. In quadrant, that's quadrant 1. In quadrant 2, I know theta is going to equal pi minus my reference angle, 1.363. So pi minus the reference angle, 1.363, is going to equal 1.779. Okay, so these are my two answers, and they're both radians. These are the two radian angles that are going to give me a cosecant of 1.0219, or a sine of 1 divided by 1.0219. And then the last one, again, we're going to do the same thing. It wants us to find the angle once more over this interval in this single rotation, and they want us to keep the answers exact. So again, it wants to know the tangent of what angle is going to equal 1. And this is one that you want to memorize. If you look, these are our special ones, right? These are the ones that you're already noticing that you can do this. It doesn't say to use your calculator. Oh, yeah, it does. It says to find your exact answers. Once they say exact, guys, that means no calculators, okay? And so this is going to bring you back to, again, finding the angles on the unit circle for the 30, the 45, and the 60 that are going to do this. So once again, you know the tangent of some value equals 1. Well, which one is that going to be? And this is one you want to memorize. The tangent of 45 degrees is equal to 1 always. And so again, 45 degrees, you know that the x is square root of 2 over 2, square root of 2 over 2. And so again, if I do y over x, I'm basically doing square root of 2 over 2 by itself, which is obviously going to be 1. So you definitely want to memorize that tangent of 45 equals 1. In terms of radians, however, you know that the tangent of pi over 4 is equivalent. So I know that my reference angle in quadrant 1 is pi over 4. Now, I need to figure out in what quadrants is my tangent positive, right? All students take calculus, and I know in quadrants 1 and 3. So my reference angle being in quadrant 1 is definitely one of the angles in this interval. The other one is in the third quadrant, and for that one, I know that it's going to be pi plus pi over 4, and I know that 4 pi over 4 is the same as pi, so plus pi over 4, and that's 5 pi over 4. So using the unit circle, I know that I have two angle measures, pi over 4 in quadrant 1 and 5 pi over 4 in quadrant 3, that have a tangent of 1. Okay. Again, which quadrants, what angle measures is going to give me a cosine of -1/2. Remember that our cosine, guys, goes with the x value. So I need to figure out in my reference angles in quadrant 1 which variable or which x value, right, has the half as its x, right? And I know that it's the 60 degrees. I know that 60 degrees, or pi over 3 radians, I know that the fraction is -1/2, and then it's, or not -1/2, but it's +1/2, and radical 3 over 2. Those are my xy coordinates for that. So I know that my reference angle for this problem is pi over 3 radians or 60 degrees. Okay, that's the one that gives me the x and y, x a half and y radical 3 over 2. Now, because here it's negative in this problem, I know that my cosine, all students take calculus, my cosine is negative in quadrants 2 and 3. So I have to figure out then what are the angle measures in those. Okay, so if my reference angle is pi over 3 in quadrant 2, right, I know that the angle I'm looking for is going to be pi minus pi over 3. Again, I've got to convert pi into something with a denominator of 3, so I'll make it 3 pi over 3. And I know that that's going to give me an angle of 2 pi over 3. So 2 pi over 3 in quadrant 2 is going to give me a cosine of negative a half. And then I'll go to quadrant 3 and do the same. I'll do the formula. In quadrant 3, I know the formula is pi plus pi over 3. Pi is the same as 3 pi over 3. And so when I add it and do the math, it's 4 pi over 3. So I know that in this quadrant, 4 pi over 3 is the angle that's going to give me a cosine of negative a half. And so I know that my reference angle is pi over 3, and when I apply it, these are the two angle measures that are going to have this cosine. Okay, this pi over 3 was just my reference angle. Okay, but these are the actual two solutions. Okay, so let's go to the next problem. We've got here, I know that my sine or my y value is a half. So again, let's think about that. I know that I have an ordered pair. There's a reference angle, okay, that's going to have an ordered pair. The x is going to be square root of 3 over 2, and the y is going to be a half. And I know that this is 30 degrees or pi over 6 radians, okay? And so I know that I'm dealing with a 30 degree or a pi over 6 radian. Since this is in radians, I know that my reference angle for this problem is going to be pi over 6, okay? By looking at the problem, I know that my sine, all students take calculus, and I'm really just looking at the half, okay? The negative a half, I'll apply that in a minute, but I look at a half and I'm just thinking of quadrant 1, and I know that the only one that has a y value of a half is the 30 degree or the pi over 6. Now, since it's negative, now I focus on the negative, and I know that my sine is negative in quadrants 3 and 4. Okay, so in quadrant 3, I'm going to find my angle by doing, I know the formula is pi plus pi over 6. So I know that pi plus pi over 6 is the same as 6 pi over 6 plus pi over 6. And that's going to be 7 pi over 6. So that's one angle. And in quadrant 4, I know my formula is 2 pi minus pi over 6. 2 pi is the same as 12 pi over 6. That simplifies to 2 pi, but it helps me do my math and gets me 11 pi over 6. So these are my two solutions for this problem. I know that in quadrant 3, 7 pi over 6, and in quadrant 4, 11 pi over 6 has a sine of negative a half. Last problem I'm going to do here, and I think again my cosine is my x value, so I need to find a reference angle that has an x value of radical 3 over 2, and I know the y value will be a half. I'm looking in quadrant 1 of my unit circle, and I know that my reference angle is going to be, again, 30 degrees or pi over 6 radians, okay? So again, I look to see, and I see that it's positive. All students take calculus. My cosine is positive, so I know that the only quadrant that my cosine is positive in is in quadrants 1 and in quadrant 4. Those are the two quadrants where my cosine or my x's are positive. So in quadrant 1, I know that the reference angle is the actual angle. So I know that my answer is just, in that one, it's just pi over 6. My reference angle is the answer. And in quadrant 4, I know that the answer is 2 pi minus pi over 6. So it's 2 pi minus pi over 6. 2 pi is the same as 12 pi over 6. And so again, 11 pi over 6 is the answer for this one. So this one I know is pi over 6. And those are my two solutions for this last problem. I know, again, what we're saying is that in quadrant 1, pi over 6 has a cosine of radical 3 over 2. And in quadrant 4, 11 pi over 6 has a cosine of radical 3 over 2. And so that's how we solve these problems. I know that, it can be a little bit tricky, but when you get used to it and you memorize the process, I think you'll start finding that it gets easier and easier. Again, you're going to have to memorize the ones from the unit circle, okay? And again, you should be able to get that. Remember that 30 degrees is pi over 6, and it's square root of 3 over 2 and a half. 45 degrees is pi over 4, and it's radical 2 over 2, radical 2 over 2. These are all the ones in quadrant 1, okay? And the 60 degrees is pi over 3, the x value is a half, and the y value is is radical 3 over 2. And once you know these guys, then you know. If somebody tells you the sine is a half, you know it has to do, or actually that would be cosine, right? If the sine is a half, you know the y value is the half. It's got to be 30 degrees. If the cosine is a half, well, then it's got to be the 60 degrees or the pi over 3. If the sine is radical 2 over 2, it's got to deal with 45 degrees. And then you focus on the quadrants and the positive and negative after, once you know exactly what angle you're working with.